Hey, what's going on everyone? This is Big Brace channel. My name is Amir and welcome to a new Rust tutorial. In this video, we are going to build a simple web application using Rust and WebAssembly. Now, the WebAssembly part is the new part in my Rust content on the channel. In this video, we're going to do different things. The first thing, we will have an introduction to WebAssembly, and I guess that's why you have clicked on that video. You will understand what WebAssembly is and how it works with Rust and JavaScript. Also, we're going to set up our project. We're going to create a new Rust project and we'll configure it for WebAssembly. Obviously, we're going to write Rust code. We're going to implement the logic for our web application. And our web application, by the way, is a tax calculator. This application is written in Rust. So after writing the Rust code, we're going to build the project. So we're going to use wasm-pack to build our project. Next, we're going to set up the web environment by creating an HTML file to load the WebAssembly module. And we're going to provide, of course, the user interface that you see right here. And finally, we're going to use a simple HTTP server to serve the project here and test it in our web browser. Now, if we'll take a look to WebAssembly website, so that's WebAssembly.org. Just give me a second. I want to open, zoom it. So take a look here. That's WebAssembly.org. You can browse that website. It's going to give you an introduction, not only an introduction, but it's going to give you all of the information that you need when it comes to WebAssembly. That's the main website where you can have your basic information about WebAssembly. So yeah, I'm going to explain in a moment what WebAssembly is. But one thing to notice directly in this website that, of course, the main objective is to write Rust code, to compile the Rust code to WebAssembly format. This WebAssembly format is going to work with JavaScript to render everything on the browser. It's as simple as that. By the way, you can write C++, you can write C, any other programming language that can be compiled to WebAssembly. This WebAssembly is a format that can work with JavaScript in order to render your application to your web browser like the one you see here. The main thing that you can see directly in this part, at least, that tells you WebAssembly 1.0 has shipped in 4 major browser engines. And you can see that this is Mozilla Firefox, Google Chrome, Safari, and Microsoft Edge. However, I'm running this application on Brave. That's my favorite browser. So yeah, it's being developed. They're adding other web browsers where you can run your application or serve your application to those browsers. The tax calculator, the idea of the tax calculator is very simple. You will enter your income and you will hit calculate tax and it's going to calculate your tax. That's just a simple web application that showcases the usage of WebAssembly and how you can write Rust code, compile it to WebAssembly, and render everything to the browser. All right. So I'm not going to go in details here, but let's talk a little bit about WebAssembly. What is WebAssembly? This is, by the way, another website. So that's rustwasm.github.io/book. Okay, WASM, it's the abbreviation of WebAssembly. You can see here I wrote WebAss, but that's WebAssembly. All right. So yeah, the abbreviation is WASM. Do not confuse WASM with NASM. NASM is the net-wide assembler for assembly language. WASM is just, I'm going to tell you now what WASM is, or WebAssembly is. So if you will get back here to the website, it tells you that WebAssembly, abbreviated WASM, is a binary instruction. So binary means 0 and 1 instruction format. Okay, so now we know that WASM is a format for a stack-based virtual machine. WASM is designed as a portable compilation target for programming languages, enabling deployment on the web for client and server applications. And this WebAssembly format can run in web browser. So you will write your Rust code, you will compile it to WASM, and WASM is going to run on the web browser. You can use the high performance of a powerful language like Rust, allowing you to leverage the performance of the WASM for the compute-intensive tasks that can be very difficult for JavaScript, for example, to handle. So anything that it's hardware intensive or compute intensive task can be leveraged using WebAssembly, which is in itself a compiled format from Rust. And you can use that WebAssembly format with JavaScript to run your application on the browser. Now, WebAssembly modules can be written in different languages, like I told you, not only Rust. You can write it in C. You can write it in C++. If you want to know more about Rust, I have a lot of videos, 2 courses, 1 crash course and 1 full course for beginners, and a lot of other videos explaining different concepts and fundamental, building blocks of the language itself. But also I have different applications, mainly CLI applications. You can check all of those videos out if you don't know or if you have no idea about Rust. But I'm going to assume that you know already Rust. And by the way, the Rust code we're going to write is not complicated at all. Even if you have not written one code line in Rust, you will understand it perfectly. But I will assume, of course, that you have some knowledge in any other programming language. All right. At least you should have some knowledge in programming to follow along and feel comfortable. Otherwise, I'm sorry to tell you that you will feel lost. So I'm inside a folder called Rust-WebAss or WebAssembly, and I'm going to open this with Visual Studio Code. Now I want to create a project. I'm going to use cargo, so cargo new, and let's call it tax wasm, for example, right? Let's cd to tax wasm. And let's take a look here on the left side in the source. So in cargo.toml, we will need to change different things. So I will need a dependency called wasm-bind-gen, and that's version 0.2. So that's 0.2 here. Save, and it's going to give you this check mark that it's okay, this version is valid. And wasm-bind-gen simply is a crate that facilitates the interaction between Rust and JavaScript when we are targeting the WebAssembly. So think of the wasm-bind-gen dependency as a bridge between Rust and JavaScript. The second thing that I want here is lib or library. So for the library, and this section is very important in our wasm project, by the way. In any other Rust project, you will not need this, most probably. But in wasm projects, you need this. So the library section is used to configure the settings for the Rust library we are creating for our wasm project. So I'm going to type crate type. Now, this is going to specify the type of output that the Rust compiler should produce. You need to understand that in Rust, a crate, and this is something that I've never touched in my courses or my other projects. So in Rust, a crate is a compilation unit, okay? The crates can be either binary, which means executable, .exe, or libraries. And this compilation unit, or in other words, the crate, would result in one of 2 different outputs. Either it is a binary or executable output, or a library. So usually when we compile our Rust code, we have our .exe file, the executable, the binary. And also we can have a library output. In this case, we will concentrate on library. So that's going to be inside those brackets, inside double quotes, and I'm going to write cdylib. cdylib. So cdylib stands for, and that's not really important, but I'm going to tell you anyway. So cdylib stands for C compatible dynamic library. C compatible dynamic library. When we're going to target WebAssembly format after the compilation of our Rust code, this type here is going to indicate that we want to produce a dynamic library that can be used in environments expecting C-compatible calling conventions. We're not going actually to compile an executable, we're going to compile a module, a library. This WebAssembly module can be used with JavaScript. Alright, before we get started to the coding part, there is a very important thing that I want to point out too. So to create a project in Rust that's going to be compiled to WebAssembly format, you can do cargo new and the name of your project. But you can also do like this, --lib. That's going to create this instead of, inside the source, instead of main.rs, that's going to be library.rs. So actually what I will do is that I will delete cargo.toml. I will delete .getignore. I will delete the source here, that file. And also I will delete the name, the project itself, that folder. So let's try that one more time. I will do cargo new tags hyphen WebAssembly, and I will do --lib, and I will hit enter. Now, if you will take a look to the tags WebAssembly folder inside the source, I have here lib.rs, and the components different from a normal main.rs file where we have our hello world, right? We have here a public function add left, right, then it returns unsigned size left plus right. All right, so that's a template. We don't actually need all of that. So I'm going to remove all of that, and don't forget to re-add in cargo.toml our dependency. So we need the wasm.bindGen, and also for the library, I have here my crate type to be equal to the C compatible dynamic library. All right, awesome. Let's now go to the lib.rs and start coding our application. So first of all, I want to import the wasm-bindgen prelude. Next, I want to have an annotation to indicate that the function that's going to do the calculation of the tags is accessible from JavaScript. So I need to make sure that this is a public function, and I'm gonna call it calculate tags, and that's of course will accept income as an input of floating 64 data type, and that returns floating 64 data type as well. Open curly brace, and I want to initialize the tags variable. Tags variable to initially 0.0. That's the initial value of the tags. So initialize. I don't know why it's complete. Initialize. Sorry. Right. So first of all, I want to have a variable called tags, and that's going to be equal to 0.0. But don't forget that this tags variable should be a mutable variable, and let's give it a data type of f64. If you will leave it like that, it's going to do type inference, but just for clarity, I'm going to type it. Now I want to check if the income is less than $9,975. So that's not 100,000, but 9,875, right? US dollars. So I'll say here if income, by the way, here I want to have this wasm-bindgen, the module itself, just without all that. So if the income is less than or equal to 9,875, that means that I want to calculate my tax by taking the income and multiply to it 0.10. Else, if income is less than or equal to 40,125.0, in this case, the tax is going to be equal to 987.5 plus the income. So the income minus 9,875.0 multiplied by 12% or 0.12. Right? This is calculating the tax for the first $9,875 at 10%, and the remainder is going to be calculated at 12% tax rate. Else, if income is equal to or less than 85,525.0, because that's F64, every time we need to put 0.0 because we have determined the data type to be F64 or floating point 64 bits. The tax here is going to be equal to 4,617.50 plus, now the income, I'm going to deduct from the income 40,125.0, and I'm going to multiply that by 22%, 0.22. Right. And again, that simply means that you're going to check out if the income is less than or equal to 85,525. We're going to calculate the tax for the previous brackets, and the remainder is going to be calculated at 22% tax rate. Next, I want to check if the income is less than or equal to 207,300 $350. In this case, I'm going to calculate the remainder at 35% tax rate. That's a high tax rate, by the way. So the tax here is going to be 33,271.50 plus income minus 163,300.0 multiplied by 0.32. Else if the income is less than or equal to 518,400, in this case I will calculate the remainder at 35% tax rate. So yeah, that's going to be this way. That's tab 9, not me. This is not entirely accurate. Here is 47,370 or 67.50, and the income will deduct from that 207,350.0. And finally, any other salary above $518,400, the tax rate is going to be 37%. Right, so we're going to say here else, and the tax is going to be calculated on 156,235.0 plus the income. We're going to deduct from the income 518,400.0, and we're going to multiply that by 0.37. And then at the end, we want to return the calculated tax. Right. So simply you're going to just return the tax. So that's it, guys. This is our Rust code. So even if you have never written one Rust code line, I think this is pretty understandable. It's a very simple conditional checking with if-else statement. By the way, guys, there is another tax bracket here between the 85,000 and the 207,000. So can make it like that. Do like this. Do else if the income is less than or equal to 163,300.0. In this case, the tax is equal to 14,605.50 plus the income minus 85,525.0. And we're going to multiply that by the tax rate that's between the 22 and the 32, multiplied by 0.24. And that's it, guys. This is basically my Rust file. So what I want to do now is I want to go to the tax WebAssembly root directory, and I will create here in that folder index.html. Now it's going to be a very simple HTML. I'm going to do like this, a simple boilerplate. I'm going to call that tax calculator. And here that's of course document type HTML, English language, meta character set for UTF Unicode UTF-8, and meta name viewport content with device width, that's for responsiveness for smaller screens. The title tax calculator, and I will have here a link for my styles.css file. Right, so let's just open here and let's have styles.css. And as you can see that I have put comments everywhere for you guys. So for the body, you will have, simple style for the body. You will have font family, background color, which is this degree of white. The color or the font color is 333. This is a grayish color, and it's going to have flexbox layout with the elements that's going to be arranged in a column. It's going to center all of the elements horizontally, and we're going to justify the content or center all of the elements vertically. Then you will have 100 viewport height, and finally we're going to remove all of the default margin just to disable the cursor just scrolling down on the side. For the h1 tag, you will have that rust orange color, label input button, so that's going to be 10 pixels top and bottom and 0 right and left. For the input, you will have here padding inside input. You will have here the padding for 8 pixels, font size 16 pixels, the border 2 pixels solid with the orange color, and we'll give it some roundness by having the border radius to 4 pixels. For the button, we're going to give it some simple styling. For the padding, font size, background color, and so on. For the hovering and the result. Finally, that's going to be the income tax that you should pay. And simply we're giving it a margin top to be 20 pixels. That's going to be above the result text, and the font size is going to be 18 pixels with the color, which is the orange color, different from that dark rust color. All right, that's it, guys. This is for our styles. Let's get back to index. Just put it here inside. All right, maybe you can do like that. Actually, we can open this with live server. Now, as far as the body, I want to have a label and input for the income. So label for income, and here we'll say simply income. All right, and also I need to have an input, and the type is going to be, of course, number, right? And that's going to have an ID as well. We will need the ID for the JavaScript to have the get element by ID, the income. The name also we're going to income as well. And the minimum here is equal to 0. Also, I will need a button with the ID calculate tax, or calculate button rather. Let's make it calculate button. I'm gonna call that calculate tax. Right. And finally, I want a paragraph with the ID result. Again, I will need the result in the JavaScript just to plug dynamically the result of the calculation. That's going to be the tax that you're going to pay. Now, as far as the JavaScript, I want to have a JavaScript, but not with normal source. I need to have a module type. So that's going to be a module type, and the source is going to be, let's call it app.js or tags.js. Right, so let's have this file right here, tags.js. Now, before we write our JavaScript, I need to build the Rust project first. I want to open the Explorer just to show you. I will open the integrated terminal. Maybe you can do like this. I don't need that anymore. And we will need to build a project using the wasm-pack. Now I'm going to build my project using the wasm-pack, and you will have to install the wasm-pack on your computer. So to install it, you can go to this website, rustwasm.github.io, wasm-pack installer, and simply you can download and run the executable. If you're running on Linux or Mac, you can take the curl link. You can also install it using cargo install wasm-pack, or you can install even using npm install with the global flag wasm-pack, or you can use yarn if you want. Right, so I'm going to take cargo install wasm-pack. I have it already, but just let me show you cargo install wasm-pack, but as it's installed for me, so it didn't take any time. So once you're happy and everything is properly installed, you can do wasm-pack build --target web. So that's going to actually create this package folder. And of course, we have an error here because instead of the negative or minus, I've written the equal sign. I apologize for that, guys. Just make like this. Let's Control L to clear the terminal, and let's do wasm-pack build target web. All right, awesome. Now we have our package. That package folder has different files. This package.json, this is a metadata and configuration for the WebAssembly package. We have this file right here, text WebAssembly bg wasm. This is compiled WebAssembly binary that has some Rust code. You don't have to know that. These two TypeScript files, this is simply some definitions for the WebAssembly module. And finally, the JavaScript file. This is just JavaScript like glue code for loading and interacting with the WebAssembly module, right? So all of that inside this package folder. Now let's go ahead and write some JavaScript quickly and run our program and see how everything is working. So the first thing that I want to import is init and the Rust function. Remember the Rust function that we have created? What was it called? Calculate tax. I need actually to copy that, and I want to import it here in curly braces, and that's going to be from, and we'll do here dot package, right? And that's going to be from the tags webassembly.js, that JavaScript file. Hit enter, and we are good to go. Now I will create a function, and I'm gonna call it run. That's going to run basically everything. Inside it, I will have another function. I'm gonna call it calculate tags, but not this way, calculate tags like this. then I want to create a variable for the income. So it's going to be constant rather, because we don't want to change in that. And if you remember in the HTML file, our field was income and we had an ID called income. So I'm gonna wrap this in double quotes and in parentheses, and I want to do document dot get element by ID. Right, it's just like that. But that's not all, because I need the value of that, whatever the value that you're going to enter actually. We're going to parse all that parse float method. This parse float method is going to parse the income input, right? That's as far as the income. Also, I need the tax, and the tax here, I'm going to take the calculate tax method and I'm going to pass here the income that you have entered. And finally, I want to display the result, right? So document dot get element by ID, and we have here result, and that's inner text, not HTML, inner text equal to, and we're going to display whatever the tax that's calculated is. So I will say here tax is equal to with the double $sign, and we'll have here tax dot to fixed, and we'll have here 2 decimal points. All right, and that's basically everything, guys. Right. Outside that scope, I will have to have document dot get element by ID, the calculate button, because we'll need to add the event listener to the button. So document dot get element by ID, and that was hold on, for the button, I don't remember. Yeah, the calculate button right here. Right, so that's the one. Dot add event listener. I have here simply click, and on click I want to trigger the calculate tax function, and at the end here I want to invoke the run function. Be careful that our function here is an asynchronous function, right? This is going to be an asynchronous function. And before the calculate tax function, I need to initialize the WebAssembly module by having the await keyword in it. Right? This is crucial and very important. Without it, actually, the WebAssembly will not work with the JavaScript file. So you have imported init and you are awaiting for the init. And for that, you will need to turn that run function into an asynchronous function, because you're actually awaiting the calculate tax function from the tax underscore webassembly.javascript in the package folder. Now it's time to serve everything using a simple HTTP server. So to serve our project, we will need this simple web server. Without it, we can't run the server, right? So we can install it using npm, the node package manager. So you will do npm install globally, and that's going to be http-server. And you can see that it has installed the HTTP server. Now it's moment of truth. You need to make sure that you're inside the main folder here, the tax WebAssembly folder. And to run your server, you would do http-server space dot. Do not do like this. You need a space. Okay, you're running the HTTP server in the root directory in that current folder. Hit enter, and you can see that we have started the server. Now you can go ahead and click on the localhost port 8081. I think I have the other server running. I'm going to shut that. I'm going to shut this now, and I'm going to run it again. And you can see that everything has changed to port 8080. That's the default port. I had it before 8081 because I had the demo running on the other server on the 8080 port. Go ahead and click on that, and there we go. We have our application running perfectly. Let's test that. Let's do 25,000, or of course you are Rust developer. Let's see Rust developers salaries. Rust developer salary June 2024. Let's see. Okay, that's $250,000. What? No, hold on. Average yearly salary. Okay, so that's the minimum. And that's the average. Okay, we're interested in the average. That's about $150,000. Wow, the maximum is $250,000 per year. Wow, that's a lot of money, guys. Okay, let's say that you are a super Rust developer and you are earning $250,000. Calculate tax and nothing happens. Oh, okay, I should define that that's in the current directory. And we can have, before the label, we can have an h1 tag, tax calculator for Rust devs. Let's try that out one more time. Let's stop the server, Control L to clear the terminal, and let's do HTTP server one more time. And let's refresh. Okay, tax calculator for Rust devs. Now let's have an income of 250,000, calculate tax, and nothing is shown. If you will check out the web dev tools, failed to load resource, the server responded with a status of 404. What you will need to do in this case is that you will need to take everything in your JavaScript, copy that, go to your index.html and omit the source. And inside here in the script, just put everything that we have written together in our text.js file. All right. That's going to be the only way, as far as I know. Maybe there are other ways, but as far as I know, that's the only way that's going to run. So let's save that. Let's do it like this. Stop the server, run the server again, 250. Calculate tax, and there we go. All right. So that's good that we have encountered that kind of error. I don't know why, but by trial and error, I've found out that if you write in a separate tax, in a separate JavaScript file, and you will put a reference to your index.html, it's not going to give you the proper response. Now, why is that? I quite frankly don't know. If you know, tell me guys in the comments below. But the only way that seems to be working is that you embed your JavaScript code inside your HTML file. All right, and that's it guys. So we have written our Rust file. We have used the wasm-pack to build our project, and inside our project we have those different files. That's the most important, the wasm file. Tax WebAssembly.wasm. This one here is TypeScript for the modules, those actually, and the tax WebAssembly.javascript, that's going to be a glue code to work with WebAssembly, and we're going to take from here this function, the calculate tax. Actually, we have imported it here from that tax assembly.javascript file, and also we have imported the init, and we have been waiting on the init based on this synchronous function which we have invoked at the end of the file. So there you have it guys, building a Rust application with WebAssembly. If you have any questions, please let me know in the comment section below. Thank you so much guys for watching, and I will see you in the next one. Till then, stay safe and be well.